All right, y'all. Today we're going to be talking about slope, which slope is what we call the rate of change. It's something that y'all learned back in middle school, but we're going to expand upon it a little bit here in Algebra 1 and actually use that slope to kind of tell us a lot about different situations and particularly linear situations and linear graphs. Okay, so in middle school, you learned rate of change or slope is known as rise over run. And rise over run is really going to be that key core piece that we keep going back to help us out with our slope formula. So there's a couple of things that we use to kind of remember slope. And the first is that rise over run, it's kind of an abstract word, but it really means the change in the y value over the change in the x value. So rise, that change in the y direction, that up and down, and then run, that change in the x direction or that left to right. And we can actually use a very special formula to help us understand and find that rise over run. And it is that slope formula. So the slope formula is y2 minus y1 over x2 minus x1. And that, of course, is equal to m, which m is the variable we're going to use to represent slope. So that y2 minus y1, that's representing that change in y, that change from 0.1 in my y value to 0.2 in my y value, and that change in x from 0.1 in my x value to 0.2. So this uses any 2 points. So if I have x1, y1, and of course x2, y2, I would consider this to be 0.1 and 0.2. So if I have 2 points, then I can find slope. And that's going to be a common theme as we work today, that as long as I have 2 points, if I have two sets of xy values, I can find slope. So let's look at our first example, and we're going to find the slope between these 2 points. So looking at A, we have the point 2, 8, and we have the point 4, 7. And what I find is most helpful is to go ahead and label these points as x1, y1, and x2, y2. And once I have those points labeled, all I have to do is plug them into my slope formula. So y2 minus y1 over x2 minus x1. So 7 minus 8 over 4 minus 2. So just continue to point out that I am plugging in those y2 and x2 points first, 7 and 4, and those y1 and x1 points second, 8 and 2. And then I do have that subtraction in between. So I can type this into my calculator if I want to, or I can of course do it by hand. So 7 minus 8 would be equal to -1. 4 minus 2 would be equal to 2, which would give me a slope of -1/2. Okay, and of course, just like we've been doing before, if I do get a fraction, I want to leave it as a fraction. I don't want to convert that to -0.5. And one of the biggest reasons why I'm going to leave it as a fraction is because we want to be thinking of that slope as that rise over that run. And so this is really telling me that I'm going to rise by -1, which means I'm going to go down by 1 for my slope, and run by 2. So I'm going to go to the right by 2. So we want to keep any slope in a fraction if we can, because it's going to tell us that rise over run value. Okay, so let's do another one. B, if you want to try and do B by yourself, you can pause me, or you can go ahead and do it with me real quick. So once again, I want to label my points. X1, X1 and Y1, and then X2 and Y2. And then once again, I'm plugging it into my formula. So Y2 and X2 first, so 9 minus 3 over -2, and then -1. And then from here, 9 minus 3 would, of course, give me 6. -2 minus 1 would give me -3. 6 divided by -3 would be equal to -2. And so -2 is my slope. And I did just mention about writing these as a fraction. So -2, of course, is not a fraction, but if I wanted to represent it as a fraction, I could also write this as -2 divided by 1. So if I divide anything by 1, it's the same value that it is. So dividing -2 by 1 does not change it. It's still equal to -2. But now I can think of this in that rise over run form. So that means this is going to go down by 2 and to the right by 1 for that slope. Okay, so that's kind of how we find slope from 2 points, but we can also find slope from a graph. So if I am given a graph like the one I have over there on the left, okay, I could use that slope formula. So I could take these 2 points right here and I can do my slope formula. Okay, and that is totally fine if we want to do that. But we can also, once we have a graphic representation of slope, we can just look for that rise over run. So if I want to find that rise over run, I can just start at my first point. I always want to do left to right, just like we read the graph left to right. So from my first point right here, to get to my next point, I would have to rise by 1. So I'd have to go up by 1. And then to get from this point over there, I'd have to run by 1, 2. And so since I have to rise by 1 and then run by 2, my slope in this instance would be a rise of 1 over a run of 2, so 1/2. And it's really that simple and that straightforward. Finding from a graph, I'm just finding those 2 points. I'm looking for that rise over run. Now, this graph right here, notice how as we go from the left to the right, it is increasing in value, and that gave us a positive value for our slope. A little different than the values we got over here. Over here for both of these, we got negative values of slope, which should make our graph decrease. So if I wanted to kind of represent that over here with my slopes, any positive slope would be going up from left to right. Any negative slope would be going down from left to right. Okay, now these two are a little bit harder. A slope of 0, think about it. If I'm trying to ask you what's the slope of something and you said there's 0 slope, that's like saying there's no slope. So if something's not sloped at all, then that means it's perfectly flat. There's no slope. It's nice and level ground. So a slope of 0 is going to be a perfectly flat horizontal line. Okay. Now an undefined slope, as opposed to 0, which is a perfectly flat slope, an undefined slope is something that's so sloped that we can't even define it. It's such a big positive or negative number that we can't even define it. And it ends up coming out kind of, instead of horizontal, perfectly vertical. So a 0 slope is that perfectly horizontal line, and undefined slope is going to be that perfectly straight up and down line. And then the last thing we want to talk about on this front page is how we can kind of identify and see slope in our different equations. Okay, so we're not going to really write equations yet. We're going to get to that a little bit later, but we do want to start being able to kind of identify slope in our different linear equations. And there's one that should be familiar. You've talked about it before, what we call our slope-intercept form. And our slope-intercept form is y equals mx plus b. And you might notice one variable that's very important that we've seen before, that m. That m, of course, does still represent our slope. And then, of course, y and x are still y and x. And then you might remember this from before, but if not, that's okay. That b does represent our y-intercept. And we're going to talk about this equation a little bit more once we get to graphing and writing. But for right now, the really important part is that m in the equation is that slope. Okay, now these other two equations might be new for you this year. If they are, that's okay. If they aren't, awesome. Okay, but the first one we call is our point slope form. You're going to see some familiar variables in it. Once again, y minus y1 is equal to mx minus x1. Okay, and just like we saw in our slope-intercept form, our point slope form also has that m, which represents our slope. Okay, but what this one also has, see that x1 and that y1, that's actually the x and y value of a point, just like we identified in our slope formula. And the very last form that we're really not going to talk about much more for right now, because it doesn't actually involve slope. In fact, if we see an equation in this form, we're going to have to change it if we're worrying about slope. But it's what we call our standard form, ax plus by equals c. And all of those should be unfamiliar because they are all different than what we've talked about before. So this a is our x amount. This b is our y amount. And then last but not least, this c down here at the end is actually what we'd call a total. And this standard form, don't worry about it for right now on our slope. If you see an equation in standard form, we're actually going to change it to be in point slope or in slope intercept form. So it's good to be able to recognize it, but it's not really a form that we want to be able to write and to use right now. We're going to focus on that a little bit more later in the unit. Okay. So flip on over to the back, and we're going to kind of talk about slope in some other different contexts. So just a reminder, we started this off, but slope can also be called rate of change. And so sometimes you'll see a question asked for the slope. Sometimes you'll see a question asked for the rate of change. If it asks for the rate of change or if it asks for slope, it's going to be exactly the same thing that you're finding. Okay, and we're going to kind of, on the front, we did slope from 2 points. We did slope from a graph. We're going to focus on 3 other ways that we could be identifying and finding slope right now. And the first one we're going to narrow in on is finding rate of change or slope from a table. Okay, and a table of values is really just like a table of points. So we could, if we wanted to, use our slope formula. We could just pull out any 2 points. Like if I wanted to, I could take 0.1 and 0.2 here, and I could use that slope formula to find slope, which would be totally fine. But if we do have this table of values, we can kind of shortcut it a little bit instead of using that slope formula. And instead what we can do is we can think of it as in terms of that change in y over change in x. So as I'm going from y value to y value from 1 to 5, the way I would do that is I would add by 4. Okay, and then to get to my next y value from 5 to 9, once again, I would add by 4. Okay, then over on my x side, to get from x value to x value, 3 to 5, I would add by 2. And to get from x value to x value, from 5 to 7, I would add by 2. And what I notice, am I changing by the same in my y direction for both points? Yes, plus 4 and then plus 4. Am I doing the same for my x points, plus 2 and plus 2? Yes, so that means I know this is a rate of change relationship. And since I know it's a rate of change relationship, I can plug this straight into that change in y over change in x. Which of course we know that's rise over run or slope. So our change in y over change in x is equal to positive 4 over positive 2, which positive 4 over positive 2 would of course simplify down to just be 2, which means our m value or our slope is equal to 2. So maybe a little bit faster than doing those 2 different points for slope. If you prefer using the slope formula, of course you can use the slope formula, or you can kind of use this little trick for your table. So let's do another one. If you want to, go ahead and pause me if you want to do this table on your own. If you want to do it with me, you can just keep following along. So once again on this table right here, from y point to y point, so 10 to 5, I would be subtracting by 5. And then from 5 to negative 5, that time I'd be subtracting by 10. So that's not the same right now, but let's see what happens on the x side. So from 1 to 2, I would add by 1. And then from 2 to 4, I would add by 2. So once again, not the same. And when that happens, I can kind of compare them. Okay, because I still want to check, is this still a linear relationship? Is this still rate of change? Am I still finding slope? Okay, so let's take our first set, that -5 and that 1. So -5 over +1 would simplify down to -5. Now let's take that second one, -10 over +2. That would also simplify down to -5. So even though my change in y and my change of x was different, they did still give me that same rate of change or that same slope. So I do still know this is a linear relationship, which means I do still know that my slope in this case would be -5. Okay, so that is slope from a table. Let's transition a little differently. In this one, we're going to have to do less math, but a little bit more thinking. We're going to do slope from situations or a word problem or a verbal description. So somewhere where maybe they've given you kind of an example, and we're just trying to pull slope out as opposed to necessarily solving for slope. And to help us out, we want to think of some words that could tell us slope. So remember, slope is a rate of change. It's comparing that change in y to the change of x. So it should be comparing two different quantities or two different amounts. So some of those words we want to look for when we're thinking about slope would be per, each, all right? Maybe a changing. Sometimes you might see like increasing, which could mean a positive slope. Or of course a decreasing, which would mean a negative slope. So there's lots of different words that kind of fall into those categories that could tell us that's a slope, that it's positive or negative slope that we could use to kind of identify in our word problem. So let's look at our problem. So Angel bought a plant that was 4 centimeters tall. So I think that 4 centimeters tall could be important. At Angel's green store, after a couple of weeks, she noticed that her plant was growing 1.5 centimeters each day. So I think this growing might be important. And then, of course, the 1.5 centimeters each day. What is the slope of this situation? Okay, so looking at our buzzwords, we have that each that popped up right here by 1.5 centimeters. So 1.5 centimeters each day. So that's telling us our two things that we're comparing, centimeters each day. So those are our two different quantities. And it says it's growing. So does growing fall in that positive or negative? I think it falls in that positive. Growing, it's getting bigger. So I believe our slope is going to be a positive 1.5. And it actually gives us those quantities, centimeters each day. So we can write our slope as m is equal to 1.5 centimeters. And then this little slash, it's like a fraction. Okay, it's like a dividing sign, but it means per or each. And so centimeters per day. And that's our two quantities that we're comparing together. Okay, last but not least, last thing we're going to talk about with slope is identifying slope from an equation. And when we're identifying slope from an equation, the first thing we want to do is kind of identify what type of equation it is. So looking at this equation here, we have y is equal to negative 10x plus 15. Okay, and the most common equation we're going to run into is that slope-intercept form that we talked about earlier. So y equals mx plus b. And just as a reminder, that slope is that m variable. So looking at our first equation, we have y equals negative 10x plus 15. So this is in slope-intercept form. Y equals some number x plus another number. And that m is always going to be that number right in front of our x. So negative 10x. So that means our slope is equal to negative 10. One of the big misconceptions I see with this, y'all, is wanting to say slope is negative 10x. Slope does not involve any variable. Okay, so slope is always going to be a number or a quantity. So in this case, we just want to pull out that negative 10. So m is going to be equal to negative 10. Right? And then number 2, we have 20 minus 3x is equal to y. Okay, now this one looks a little wonky because our y is on the wrong side, but is our y still by itself like slope-intercept? It is. Y equals. And then we have our 20, which is our b, and our negative 3x, which is our m. So we are still in slope-intercept form. In this case, it's that negative 3 right there. So m would be equal to negative 3. All right, y'all, and that kind of covers slope from all of our different ways. We can find slope verbally, we can find slope from a table, we can find it from an equation, we can find it from a graph, or of course, we can find it using our slope formula. So go ahead and practice some of these and see if you can apply them to identify and find some different values of slope.